Question is asking. Question is asking from a point. From a point. Name of a point is P. From a point 10 centimeter away from the center. Center of the circle. It is saying that draw a circle. Draw a circle and what? Draw a circle. There is a point. What? There is a point from the center of this circle. Center will appear here, and there is a point. How much is the distance from this point to this point? 10 centimeter. 10 centimeter. This is a 10 centimeter. Now, a tangent PT of length 8 centimeter is a draw. Tangent. Suppose we will draw tangent. This is what? Tangent. So till here, from here to till here, measure of this is how much? 8 centimeter. Find the radius of this circle. Find the radius of the circle. So this radius you have to tell. Let's say name of this is O, and this was P, and this is T. Now you can see we have drawn the exact figure that question is the same. This figure is telling this question. Yes, you can see. Here you can see. This point is far away. This point is this point is away from this center, and measure of this is 10 centimeter. Now you can see PT. So PT is a what? Tangent. Of course, here we cannot say that PO is a tangent. PO will not be a tangent at all. Yes, PT is a tangent, and measure of this is 8 centimeter. So second sentence is complete. Find the radius. So we will find this radius. Okay, this radius. You can see, as we know that this is 10. 10 is a more. 10 is a more, and 8 is a less. So now easily we can say that we will consider this 10 as a hypotenuse. Okay. When we will subtract this from this, we will get 40. We will apply what? Here you can, we will apply Pythagoras theorem because of we have a right triangle. You can see we have what? Right triangle. That's why we will apply Pythagoras theorem. Pythagoras theorem is used for right triangle. So to find OT, we will have to use Pythagoras theorem. Okay, let's solve. PO square. So I think direct I will write OT. To find OT, PO square minus PT square. Clear? PO is 10. PT is 8. OT square. Now from this equation we will get what? OT. OT, which is the radius of the circle, and this is what question was asking. 100 minus 64. OT 5 and 9. So I think 5, 7. So I think 3. But here So this would be 6. This would be 6. And here it is how much? 3. 36. So finally OT came as a 6. As a 6. Meaning of this answer is what? This is a 6 centimeter. So finally we got the OT as a 6 centimeter. Clear? That's how you will apply Pythagoras theorem, where you realize, you think that we have a right triangle, then you should apply Pythagoras theorem. And now that's how you will draw from the question, which will tell you exact equation. Now next question. This is what is equation front of you, in front of you. Shall we solve this together? A tangent PQ. PQ is a line which is a tangent at a point P of a circle. Meaning of this is what? There is a circle. PQ is a what? Tangent, like that. So this at a P of a circle, we will consider this P. If this is P, so of course this will be Q. Of radius 5 centimeter. So radius is how much? 5 centimeter. Meets a line. Meets a line through the center O at a point Q. So this will meet like that at point Q. So that OQ can make 30 centimeter. Find the length of the PQ. Where is the PQ? This is PQ. So of course we cannot say that this OQ will be tangent. No. PQ is a tangent according to this question. Now here PQ at a point P of a circle of radius 5 centimeter meets a line. Okay, meets a line through the center. Through the center, like that. O at a point Q, like that. It will start from here, then it will meet here. So that OQ can make a measure of a 30 centimeter. Find the length of this. We have to find this. Now, as we know, this is considered as a this is considered as a hypotenuse. It is a bigger. It is a bigger than this. Okay, that's why we will take this as a. Always you take this which is not a tangent, which is also not a radius. So this line you take it as a hypotenuse. Okay, and this is this. This is perpendicular. You can. So here, what this is big OQ square AQ square plus OP square. When we will subtract this from this, we will get this. So can I directly write Q? So QO square minus PO. QT square. QO is a 13 centimeter, and this is a height 169.25. Here 4 again 1. So QP came as a 12. Meaning of this is what is measure of this tangent line is 12 centimeter. 12 centimeter. Clear? So finally this is answer. This is what it is answer. Is our answer correct or not? You can check. Even you can check. How will you check? OQ is how much? OQ is okay, this much. PQ 12 and OP is 5. Now you will realize at the end what this will be equal to this 169, as you know, 144 plus 25, 169, 961. So LHS is equals to RHS. That's why it is said that sum of this and this will be equal to this. So that's why 12, which is answer, is correct, because of LHS RHS is equals to. After substituting 12 centimeter in the Pythagoras in place of PQ, then we got both sides equally. Both sides equal. That's why it is said that sum of perpendicular and the base is equal to sum of hypotenuse. Next question. this is computation. Write this. What is that saying? Now here, look at this. In the given figure, you will have already given figure. So in the given figure, AB is a diameter. AB is a diameter. Okay, AB is a diameter of a circle with a center O. Okay. And AD is a tangent. Where is AD? AD is a line which is working as a tangent line. If angle AOQ is a 58, find ATQ. ATQ. Question is to find ATQ. Now tell me, is it making 90 degree or not? Tell me. Can you say? Yes. Because of it is a tangent line. That's why. We have only one triangle. Only one triangle. ABD. Yes. So can we find this? By this? As we know, this is half of this. Can we say angle ABT? Angle ABT? No. ABQ. Yes. ABQ is equal to 1/2 multiple angle AOQ. Angle ABT 1/2 multiple angle AOQ is how much? 58. 2 2s are 2 9s are 29. Meaning of this is 29. This is how much? 29. Now when we will take this as a x variable, then we can get a value of this. How? From triangle ABT. So here 90 plus 29 plus x is equal to 180. X 180 minus 90, 110, 190. X now how much? 1 6. 1 is 61. So it is saying that this is how much? 61. So finally we can say x is what? APQ is what? 61. How much? 61. We cannot say that ABQ is a triangle. No triangle. So our answer is correct. Now next question. Here you can see we have to prove in the given figure P and circle of triangle ABC. ABC, this is ABC triangle. In the triangle is a circle. So here this triangle touches the sides BC. Where is BC? BC is touching the surface of the circle. Okay, CA and BA at PQR, as you can see PQR respectively. Prove that AR, here is AR plus BP, here is BP, this is BP plus CQ is equal to AQ plus BR plus CP, and then it is equal to 1 upon multiple perimeter of a triangle ABC. So can we say that this is equal to this and this is equal to this is equal to this because of the angle. According to angle I am taking. I am not taking according to side. According to side this will be equal to this. But it cannot be equal. So according to angle I have taken that this is equal to this. That's why. So can I say AQ is equal to AR? What else? BR is equal to BP. PC is equal to CQ. C. Clear? Clear? Are you clear? According to angle, I took this equally. Now AQ is equal to AR. Clear? What else? By adding. One side and one side, another side and another side. AQ plus you can see by doing that we can get this equal to this. How? AQ plus BR, you can say AQ plus BR plus CP, isn't it? BR plus CP. Now only this is AR plus BP plus CQ. So by adding this we got this equal to this. Now we have to show that this is equal to this one perimeter of a triangle. As we know this is equal to this. So you tell me perimeter of the triangle is what? AB, BC, CA. AB plus BC plus AC is what? Perimeter. It is our perimeter. It is our perimeter. Now what else? Yes, this is a perimeter. Perimeter is what? AB plus BC plus CA. Here can we write it as AB is equal to AR plus BR. Now BC is equal to BP plus BC. C is equal to CQ plus AQ. Here you can see can we write AR plus BP plus CQ, and what else, AQ plus BR plus CP. Here, as we know, this is equal to this, so we will put a value of this, how much, this much. So can we write, in place of this, we will put this. So AR plus BP plus CQ, how much, AR again BP plus CQ. Now here you can see AR is 2 times, BP is 2 times, CQ is 2 times. Here you can see. So finally you can write AR 2AR plus 2BP plus 2CQ. 2CQ. 2 is common. Of course 2 is common. 2AR plus BP plus CQ. We will take this, we will bring this side. So perimeter would be what, 1/2 1/2 and AR plus BP plus CQ. So finally you can say, we have shown that this is equal to this and this, and we have found this here, this here you can see this is equal to perimeter half. Here you can see 1/2, which is half of perimeter of triangle ABC. So this is perimeter of this, which is half perimeter of triangle ABC. Half is equal to AR. This is equal to this. So finally we have shown. Now next question. Next question. This is complete question. This is what complete question with the figure. With the figure. Now, first we will read what is it saying. In the given figure, ABC is a where is ABC? ABC is a right angle. That means this is a right angle. With AB is equal to 6. AB is 6 centimeter. AC is 8 centimeter. And a circle with a center O has been inscribed inside the triangle. As you can see, a triangle which is inside the triangle. Calculate the value of R. We have to find the radius of this circle. The radius of the inscribed circle. Now, how to find it? You can see you have one triangle ABC, another AOB, this is one, BOC, this is another one, AOC, this is another one. One is more, FOA, AOD, like that, BOB, BOE, EOC, OFC, like that, okay, like that. So can you say that what is what I'm saying? Area of a triangle ABC. What will be 1/2 base multiple height. So base is how much? 6 multiple 8 centimeter. 2 3 is 6, 8 3 is 24 centimeters. Isn't it? So it is this is what? This is a area of this whole triangle. Now we will take one triangle, this one, and this one another, this one another. So first let's start from AB, AOB. AB will be as a base and OD is a what? Radius. So we will take it as a height. B multiple H, yes. So area of a triangle AOB 1/2 multiple, so here 6 multiple R, 2 3 are, so 3R. 3R is the area of a triangle AOB. Area of a triangle AOC 1/2. So here AC is a base which is 8 centimeter and height is OA which is R, 2 4s are, so 4R is a area of a triangle AOC. Area of a triangle BOC 1/2 multiple 10 centimeter is a base, R is a height. 2 5s are 5R. So 5R. Now here you can see when we will take this, when we will add this, sum of this will be equal to this. This is area of this triangle, this is area of this triangle, this is area of this triangle. Now these three triangles are part of a triangle which is a ABC. That's why this sum of this will be equal to this. So can we say 24 is equal to 3r plus 4r plus 5r. From this what will we get? From this we will get r, value of r, radius. So easily you can say 7, 12r. Now here 24 upon 12 is equal to r, 12 to 0. So now you got r as a 2. So finally you can say this is a 2 centimeter, this radius is a 2 centimeter. And question was saying find the radius of a triangle of a circle which is inside that triangle. So we have found r as 2 centimeter. So that's how we solved. What did we do? We found what total area of a triangle ABC. Then we took this one triangle which is a part of a triangle ABC, second triangle AOC, and third triangle BOC. These three triangles are part of triangle ABC. That's why we took these three triangle parts. And as we know, these three triangle parts are equal to only one triangle ABC. And here from this equation we got r as a 2. We applied what formula of calculating of area of a triangle. Here you can see. Now next question. Figure is like that. this is figure. Now here, look at this question. In the adjoining figure, a circle touches all the four sides. This is circle and this is circle is touching all these sides. One is CD, second is DA, third is AB, fourth is BC. And for all four sides are touching this circle of a quadrilateral. So a circle is in the side of a quadrilateral. ABCD whose sides are AB as 6 centimeter. AB is 6 centimeter. Clear? Now this is where? This is 9 centimeter. Clear? 9 centimeter. CD is 8 centimeter. AD we don't know. This is what we have to find. Find the length of a side AD. Let's solve. So here, as we know, we can say from the theorem, this plus this, sum of this and this equal to sum of this and this, isn't it? It happens when figure is a quadrilateral. When figure is a quadrilateral. So always remember, in the figure of a quadrilateral, sum of opposite sides will be equal to sum of another opposite side. This. So this is parallel and this is non-parallel. This is parallel, this is non-parallel. So we will take a parallel, sum of parallel lines equal to sum of non-parallel lines. So here easily you can say 8 plus 6, AD plus BC. This is 9 centimeter. This is 9 centimeter. 8 plus 6, 14. AD plus 9. So finally 14 minus 9. AD is how much? 1, 5, 5. Okay. So finally AD came as a 5 centimeter. 5 centimeter. Clear? 5 centimeter. AD came as a 5 centimeter. Clear? So here we saw that sum of parallel lines is equal to sum of non-parallel lines. It happens when there is a what? A quadrilateral. There is a quadrilateral whose one pair is a parallel line and one is a pair of non-parallel line. Parallel lines. Now next question. This is complete question. This is a complete question. In the given figure, PA and PB. Where is PA? PA and PB are two tangents. Yes, we are observing that there are two tangents, which one is PA, second is PB. These are two tangents to this circle with the center O. To this circle with the center O. Clear? If angle APB is making angle of 50 degree, then what is the measure of angle OAB? OAB. This AB is not the diameter. AB is a chord. AB is a chord. OA is a radius. AB is a chord. Okay. So final question is what? Question is to find this angle. So how to find? How to find? How to find? Can we say that this is making what? 90 degree. Of course, 90 degree because O is a perpendicular to PA. That's why O is a perpendicular to PA. That's why. OA is a perpendicular to PA, in which angle OAP is equal to angle what? OAB plus what? This is not happening. If yes, this is angle. Now here you can say this is from the theorem of the circle. As you know, this tangent is equal to this, so you can say PA is equal to PB. You can say PB is equal to angle PAB from theorem of the circle. Okay, this is equal to this. Clear? So we have a what? Triangle. From triangle PBA. Now here, can we take one as a x? Both the angles are equal to opposite because of, as we saw from the theorem of the circle, if this is equal to this, then this will be equal to this because of theorem of the circle. So easily we can say x plus x plus 50 is equal to 180. 2x 180 minus 50. So here 130 upon 2, 65. X came as a 65. So meaning of this is what? This is a 65. This is how much? 65. And this is 65. Clear? Now as we know, OAB is a what? O angle OAB is making 90 degree. Sum of OAB plus BAP will make, so A angle OAP is equal to sum of OAB plus angle BAP. So angle OAP, this is how much? We don't know. This is what we have to find. So at least we know that this is we have to find. And BAP we know how much? 65. 90 minus 65 is equal to angle OAB. Angle OAB came as a 5 and 2. So this is how much? 25. To 65, 25 will make 90. And OAP is a what? Perpendicular. OA is a perpendicular. OAP is making 90 degree. That's why sum of the 65 and 25 will make both will make a 90 degree. So finally, that is how we found our answer. Now next question. Next question. Now here, this is a competition. The number of tangents that can be drawn from an external point of the circle. So this is a circle. From the external point, how much tangents lines can be drawn with this circle? As you know, from external point, only two tangent lines can be drawn. From internal points, nothing tangent lines can be drawn. From a point which is on the circumference of the circle, only one tangent line can be drawn. Now, if point is external, there is an external point. So from that external point, one or two tangent lines can be drawn. So answer would be B. Answer would be B. Next question. This is complete question. It is asking in the given figure RQ is a tangent. So OQ or OR will not be tangent. Yes, QR is a tangent to the circle with the center O. Clear? If SQ, where is SQ is a diameter which is a measure of 6 centimeters. So from here to till here is how much? 6 centimeter. Clear? Uh, this SQ is a line which is passing through the center. So now we can consider it as a diameter because of it is a passing through the center. That's why QR is a 4 centimeter. Then OR, this is OR is equal to, now 6 centimeter is not a measure of radius. To find the radius, we will divide this 6 centimeter by 2. So radius will be 3 centimeter. Now, as we know, this OR is a hypotenuse. So OR, sum of 4 plus 3 square is equal to this. OR 16 plus 9. OR is a 25. So finally OR came as a 5 centimeter. As a 5 centimeter. Clear? As a 5 centimeter. So finally answer would be 5 C. So we applied Pythagoras theorem because of question was asking that if you have given this QR which is a 4 centimeter diameter is SQ, so we can found from our method we can find what radius, and then question was asking find QR. So finally we applied Pythagoras theorem. So from Pythagoras theorem we got OR as a 5 centimeter. Even you can check how when you will put OR as a 5 in the Pythagoras theorem, then you will get OR. 4 square plus 3 square. Yes, OR is how much? 5 centimeter. Now you can see 16 plus 3 3 is 9. 25. Now you can see 5. Both are equal. That's why our answer is correct. Now next question. This is another question. This is another question. In a circle of a radius of 7 centimeter, so radius of this circle is 7 centimeter. What is 7 centimeter? Tangent PT is a tangent, of course. OP will not be tangent. PT is a drawn from a point P. From a point, it is a drawn till this point, which is at circumference. P such that PT becomes PT Measure of a PT is 24 centimeter. If O is the center of the circle, then length OP will be how much? Will be how much? As we know that this is what 90 degree, because OT is perpendicular to OP. That's all. Okay. We can apply, as we know OP is bigger, so sum of this and this will be equal to sum of OP. OP, so here 24 square minus 7 square, clear? OP is equal to 24 multiple 24, 4 4 is 61, 4 2 is 8, 9, 2 4 is 8, 2 2 is 4, 6 7 5, 576 plus 49, clear? OP is how much? 5 11 2 6. Now I think 25 multiple 25 will give us 625. 25 multiple 5 5s are then 2, 5 2s are 10, okay, 2 5s are 10, 2 4s are 2 2s are 4, 5 5 2 6. Finally 25 multiple 25, it is given us 625. That's why this is a perfect square of 25. So OP came as a 25 centimeter. It is telling us that this measure of this is a 25 centimeter. Even you can check. Even you can check when you will put this. So this will be equal to this. This will be equal to this. Of course, clear. So this is answer for this question. Now next. This is complete question. Question is asking which of the following pairs of lines in a circle cannot be parallel. Cannot be parallel. If we take two chords in a circle, then you can see this one chord. Yes, these are two chords which are parallel to each other. Now a chord and a tangent. A chord and a tangent. So this one which is a chord, and this another which is a tangent. Both are parallel. Two tangents, of course, two tangents are parallel to each other. Two diameters. So this is one and this is one. This one is a diameter. So only there will be only one diameter in a one circle. So how will it be possible that two diameters will be parallel in a circle? So no, two diameters will not be parallel in a circle. In a circle. So answer would be this. This would be answer. Here you can see we can draw another diameter like that, but all diameters are intersecting to each other. So parallel arcs do not intersect to each other.